Hi everyone, this is the quiz review for the Chapter 6 test in Algebra 1B, Mrs. Turigno's class. At the top it says quiz review number 2. This is quiz review number 1. This is the one you got in class today. I just changed the title of it and forgot to change that before I uploaded it here. So this should match what you have on your paper. Okay, so the first thing I want to point out, looking at 1 through 5, is the difference between 1 and 2 and 3 through 5. These ones are asking you to simplify. These ones are asking you to solve. Okay, that's a big difference. And notice that these ones don't have equal signs. The ones at top here, these do not have equals. These ones do have an equal sign. Okay, that's because in these three, you're going to be able to find an answer. You're going to be able to come to a point where you can say x equals 12 or x equals 4, something like that. Here, because these aren't equal to anything, you're not solving. You're just simplifying. You're just making it look pretty. Okay? So in number 1, all that's really asking you to do is FOIL. And in case you forgot, FOIL stands for first, outside, inside, last. There's FOIL. And that really just helps you keep straight what needs to be multiplied when. The idea behind doing FOIL is you're doing the distributive property. You're just doing it twice in a row. Okay, so here, first times first would be x times 2x, and x times 2x gives me 2x squared. Don't forget the square. If you're multiplying an x and an x, you're going to come out with an x squared. X times 5 is 5x. And then I'm going to go to the inside, which is negative 1 and 2x, negative 2x. And last, negative 1 and 5 is negative 5. Now looking at those four pieces, these two in the middle are like terms, so they can be combined. So your final answer would say 2x squared plus 5x. Nope, sorry, not plus 5x. I need to combine the 5x and the minus 2x, so 5 minus 2 is 3, and then minus 5. And that would be your final answer for simplifying. Same thing with number 2. The only difference with number 2 is you've got this 1/2 floating around out here. Remember, though, you need to follow order of operations. So you need to deal with the square before you deal with multiplying. So this means I'm going to write out 1/2 times 2m minus 8 times 2m minus 8. I'm going to take care of the FOIL and just leave the 1/2 alone, which is going to leave me with 1/2 2m times 2m. 2 times 2 is 4. M times m is m squared. 2m times negative 8 is negative 16m. Negative 8 times 2m is negative 16m. And negative 8 times negative 8 is positive 64. Okay. Now I'm going to combine those like terms in there. So that would bring me to 1/2 4m squared. 16 and 16 make 32m plus 64. And then I'm going to distribute the 1/2 to everything. Okay, so the distributing is the last thing I do. The only thing you would do after distributing is if there was a plus something or a minus something tacked onto the outside of the parentheses. That comes last in the list. But as it is, this would come out to be 1/2 times 4 is 2. So 2m squared. 1/2 times negative 32 is negative 16m. And 1/2 times 64 is 32. So there's a final answer, 2m squared minus 16m plus 32. Let's move on to these ones that say solve. Okay, now solving is a different story. solving, you are not using PEMDAS, you're using SADMAP. Remember we talked about this in class, that if you're simplifying, which are like these up here, the ones at the top of your page, those are simplifying, and then you're using order of operations, PEMDAS. When you're solving, you want to do order of operations in reverse. You're going the opposite order because you're undoing everything. So for these down here, you're using SADMAP, and you're doing everything backwards. Okay, it's like opposite day. Okay, so these ones we're doing SADMAP. So for number 3, I'm undoing everything. So the first thing I need to undo is subtraction and addition, which I have right here with a plus 5. So I'm going to do minus 5, minus 5. Notice that I am not foiling. So g plus 3 squared equals 25. Now I can't do anything else without breaking into these parentheses here, and I can't get into those parentheses without dealing with that square. So this is the point where I'm going to have to take a square root. I'm going to take a square root here and a square root here. When I take the square root on the left, the square root of g plus 3 squared, all that's going to happen is the square root and the square are going to cancel, and I'll be left with g plus 3. The square root of 25 could be 5, or, and this is the important part, the square root of 25 could be 5. It could also be negative 5. Okay? So g plus 3 might equal 5, or it might equal negative 5. So what I really need here, instead of tacking this onto the end like this, I need to write a separate equation. I need to write g plus 3 could equal negative 5. Okay? You have to have both of those to get your answer right. And again, I got that split because when I take a square root of 25, it could be 5 or negative 5. So I have to say this could be 5 or it could be negative 5 for this problem to work. Okay? Now I'm just going to subtract 2 from each side. That's going to leave me with, in this first problem here, g would equal 2. Or, in the second problem here, if I subtracted 3, g could equal negative 8. So it is not just a matter of solving it once and then tacking a plus or minus onto it. Sometimes you get 2 totally different answers. Okay, let's look at number 4. 2x squared plus 4 equals 2. So again, using SADMAP, the first thing I'm going to get rid of is that plus 4. So 2x squared equals negative 2. I get a lot of people who right here want to take a square root. But before you can take a square root, you need to get rid of everything outside of the square root, which includes this 2 right here. So I need to divide by 2. Divide by 2. That leaves me with x squared equals negative 1. And now that I'm down to just a square, this is where I would want to take a square root. However, I can't take a square root of negative 1, at least not with what you've learned so far. So, right here at this point, as soon as I'm asking myself to take a square root of a negative number, I can conclude that there's no solution to this. Okay. Let's look at number 5. I would subtract 6 from each side. 22 minus 6 is 16, so 4x squared equals 16. Don't be tempted to take a square root here. Okay, before you can take the square root, we need to get rid of this 4 here. So I would divide both sides by 4, end up with x squared equals 4. Then I take a square root, and remember that when you take that square root, x could equal 2 or negative 2, because when I take a square root of 4, it could be 2 or negative 2. And because I'm already down to what x equals, okay, as opposed to up here where I had g plus 3 left still, here I'm just at x, so that means that's just my answer. So I can say x equals 2 or x equals negative 2. Okay, let's look at number 6. I'm going to zoom it in so you can't see all the words. That's okay, they're on your paper. 2 neighbors' yards have exactly the same area. That's important. They want to have the same area, which means we want their areas to be equal. One is shaped like a square and one is shaped like a rectangle. Okay, rectangle you can't see. Well, as soon as I start reading this, I would probably start drawing. Here's the neighbor with the square yard. Here's the neighbor with the rectangular yard. And I know that they each have the same amount of space. Obviously they don't from my drawing, but they do have the same amount of space. Okay, the rectangular yard has dimensions 0.5 acre by 1 acre. That means this rectangle, the dimensions are 0.5 and 1. Now remember, area of a rectangle is just length times width. So to find the area of this rectangle, I'm really just going to do 0.5 times 1. And I find that that area is just 0.5 square acres. Okay, I don't know what the abbreviation for acres is. I'm sure there is one, but okay, so I have this rectangle sitting over here at 0.5 square acres. And I know that this square has to have the same area. Now I want you to think about what you know about a square. How do you find the area of the square? And some of you might be pointing to this and saying, well, it's just length times width. It is. You're right. Except in a square, all 4 sides are exactly the same. So if I'm calling this side x, then this side is also x. So when I do length times width, I'm really doing x times x, which is x squared. So the area of this would be x squared. And then I want to say x squared needs to be equal to this 0.5 because I want the areas to match. So I would say x squared has to equal 0.5. And then from here, you're just solving like an equation. You would take a square root, and x equals, oh gosh, I want to say it's in the area of 0.7. I don't have a calculator handy. Hold on. Yep, 0.71, I guess to be more specific. Now here's the thing. Normally at this point we should say plus or minus 0.71 when you're solving an equation with a square in it and you take a square root. You do need 2 answers. But in this practical situation, a negative answer wouldn't make sense because this answer represents the length of this square. And you can't have a negative length. So my final answer is just going to be 0.71. And now that I look at this, well, mathematically, hopefully you got that process down. I didn't write this problem, but I just caught this. An acre is not a linear measurement. An acre is a square area measurement. It's a certain amount of square feet, I believe, or maybe it's square yards. I'm not sure. So really my answer should be 0.71 acres, but that doesn't really make sense in this situation because you can't have 0.5 of an acre. So for this one, let's just not worry about the units, okay, because square acres, that doesn't make sense either. As I was writing it, I knew something was wrong. So just ignore the length measurements there, and your final answer is 0.71. If this had been in feet or in miles or whatever, your answer would be 0.71 feet or 0.71 miles or whatever. Just that measurement of acres doesn't really make sense in that problem. So apologize for that. Okay, number 7. Number 7 is our favorite photograph problem. You've got a painting, so I guess it's a painting, not a photograph, that is 25 centimeters by 35 centimeters. So this is 25. This up here is 35. And you have a frame around the outside. that is, oh, let me guess, W inches wide. And I want the area of the painting and the mat. So basically I want this entire area, the area of this whole thing. Okay? Which means I need the length of that bottom side and I need the length of one of the vertical sides. Okay? So the length of this side down here, from here to here, is 35. Okay, that came from my original painting. And then I've got these little pieces on either side that each have a length of W. So if I want the length of this entire side, if I were walking along this side, first I would travel W, and then I would travel 35 centimeters, and then I would travel another W centimeters. So I'm adding those together, okay? So my length along that bottom side would come out to be 35. Oh, you can't read that. 35 plus a W on either side would be 35 plus 2W. And then up the side it would be the same thing. This side would end up being 25 plus 2W. And then to find area, I'm going to multiply those two expressions together using FOIL. So I would do 25 plus 2W times 35 plus 2W. Okay? And then I would FOIL it out. So 25 times 35 is 875. That was 25 and 35. Then I'm going to do 25 and 2W makes 50W. 2W and 35 makes 70W. And 2W and 2W makes 4W squared. And when I write my final answer, I do want to make sure that I start with my square term. See, I'm going to take this and move it down a little bit, maybe. Or maybe not. Okay, that's okay. I'll just put my final answer up above here. So final answer would be 4W squared. Then I'm going to combine my W's, so that would be 120W plus 875. Okay. Okay, on to number 8. Give a simplified expression for the shaded area below. So notice the shaded area is all of this out here. On the paper that I handed you out today, the shading didn't come through real clearly, so just make sure you understand where the shaded area is. Now, when you did problems like this in geometry, they didn't have like the X's in them. They just had regular numbers. But you did do ones where you had like a larger shape and then a smaller shape on the inside, and then the in-between was what you were looking for. To find that in-between space, you want to take the outside area and subtract the inside area. Okay, so jot that down real quick. You want to do outside area. So outside area minus inside area. For outside area, what I'm really looking for is the area of this entire rectangle here. Okay, which means I'm going to be multiplying this and this. So I would be doing 3x plus 5 times 5x minus 1. Okay, then I'm subtracting the inside area, which is this times this. Since this is just a single term, it's really just going to look like the distributive property. So 2x times x plus 4. Now I'm going to work that out. So over here on the left, first I'm going to do FOIL. So 3x times 5x is 15x squared. 3x times negative 1 is negative 3x. 5 times 5x is 25x. And then 5 times negative 1 is negative 5. I'm going to go ahead and put that in parentheses to keep it separate from the second one that we're about to do. Then I'm subtracting. Now let's take that 2x and distribute. So 2x times x is 2x squared, and 2x times 4 is 8x. By the way, the other way you could have handled this is to ditch the parentheses altogether and just treat this like a negative 2x. So when you distribute it, it's going to make both of those negative. But doing it this way, this whole first parenthesis is going to stay exactly the same. Nothing's going to change in there. But this negative sign is going to be distributed to both of these things in the second set of parentheses. So this first one will stay. And then I'll end up subtracting 2x squared and subtracting the 8x. And this right here, the subtracting the 8x, is the thing that people miss the most often. Because this minus sign, a lot of people get that it needs to be attached to this 2x times x, but they don't get that it also needs to be attached to the 4. Now it's just a matter of combining like terms. So I have 15x squared minus 2x squared is 13x squared. Negative 3x, 25x, and negative 8x. 14x. There we go, final answer.